Hello everybody, this is Carbon Killed the Cat, and welcome to your 22nd Lua 5.2 tutorial. In this video, we'll be going over the I.O. library, which lets us read and write to and from text files. I know we've gone over getting input from files before, but that was reading Lua files and executing those files as Lua code. This is reading from text files, and we can put pretty much whatever we want in this text file, and then interpret it within our Lua code. So it's a different system, and within the I.O. library there are two different what are called models. The first is the simple I.O. model, and the second is the complete I.O. model. So we'll start with the simple I.O. model, so let's get started. So the first two functions we're going to go over are I.O.output and I.O.input. So we'll go over I.O.output first. And what this function allows you to do is it allows you to change where the I.O.write function prints whatever you give it as a parameter. So you give it a string that's a file name. So in the directory that I have the Lua file we're working in, I have a file called output.txt. So I'm going to give it that as a file name. So output.txt. So if you want to do this, just make a text file in the same directory that you have your the Lua file that you're working in. So we just execute this function, or call this function, and then if we use io.write after this, say io.write hello, and then we run the program, you see, even though we called io.write, there's no output here in the console. I don't know if you can see the console in the video, but there's no output here in the console. But if we go to that output.txt file, you may notice that it grew a kilobyte, and we have hello right here. And just to prove to you that I didn't have that there before, let's print out a few numbers instead, run it again, and now when we open this, we get those numbers. So the io.output function changes what's called the current out, and the current out is the file that all of the io.write calls will pass their parameters to. So by default, the current out is the standard out, which we can actually set it back to if we were to say io.output st or io.st.out. So this is how you set the io.output back to normal. Then we can say io.write 1, 2, 3, 4 again. And this time that 1, 2, 3, 4 comes up with the console. So the io.output function is just changing the current output file of the program, and any calls to io.write will write to that current output. So the next function is io.input, and it kind of does the opposite. It changes the current input of the program. So you may notice I made another text file called input.txt, and we are going to use that. And the io.input function works with io.read, and also another function that we'll get to in a minute. So since we're getting input, we have to actually put something in our input file before we can read from it. So we'll just put hello here again, save that, and close it. Or I didn't close it. There we go. Now it's closed. So io.read, or we need to set a variable to it, or just print it. So print io.read, no parameters, and if we run this, we get hello. And you'll notice I was never prompted to enter something in the console like you usually are when you call io.read, and that's because the current input was changed from the console here to the input.txt file that we have right here. So the io.output and io.input just change which file you're either writing to or reading from. So you could change the standard input to any file I shouldn't say any file that can be read from, like a text file or any modification of that. And then from that point on, or until you change the standard or the current input again, io.read will read from that file instead of the console. And just like with io.output, you can reset this by saying io.input io.standardin. And now if we call print io.read again. Then we'll be asked for input from the console, and then that will be printed out. So the standard in and the standard out are your default files for input and output, but you can change them with the input and io.input and io.output functions. So you may have noticed before when we changed our current output to output.txt that our print function still printed to the console, which is our standard output. And the reason for that is that print will always print to the standard output no matter how much you change the standard output. And that's the real reason that print is a different function than io.write. Print is more of a debug function. It's not in the debug library, which does exist. We'll go over that later. But it is really mostly used for debug. You print stuff out to the console, and mostly debug stats like variable values mid-program and stuff like that. So just as a general guideline, you want to use print for debug things and io.write for actual program stuff. So you can never use print to a text file or anything like that. It will always print to the console. And it also has its nice convenient features like adding tabs between parameters and adding an automatic new line. So those are some of the advantages of print, but if you actually want to write to a file, you do need to use io.write. So the next thing we're going to do is we're going to go over how to actually read a file and then parse out information that we'd actually want. So let's get rid of all of this except for the line where we change our current input. And I changed our input file, so now it's kind of like a configuration file for something in a game. So we have some kind of ID that identifies the object, and it's just set some random number. We have a health, it's 150, and a level, that's 10. And what we're going to do is we're going to read through this file, and we're going to parse out the numbers and just get rid of the words and the colon in front of it. So it's pretty simple. What we do is we say, actually let's create a table to store our final values. Table, and then for I equals 1, and we'll go to infinity. We will have a break in here to actually end the loop at some point. So we'll say if, or actually we have to read the line, so s equals io, make it local, local s equals io.read with no parameters. And then we will say if s equals nil, then, and I'll go over this all in a minute, just be patient for a second. It's not how you spell break. Break, and end. And then, so we're saying now if s is not nil, then we will say s equals s colon match %d plus. And we're doing this because we're trying to parse out the numbers from the file, but I'll go over this in more detail in a second. And then t at size of t plus 1 equals s. And we will call to number on this since we know it's a number. And if you don't know, to number just tries to turn a string argument into a number and returns nil if it can't. So since we know that s at this point, since we have a %d plus pattern in here, can only be a number, then it's safe to call toNumber on it since s obviously has to be a number. So now let's create another for loop here. So for I equals 1, size of t, and end, and we'll just print, print t at I. So now let's go through the code line by line, and then we'll run it and see what happens. So we create a table here. This is just to store the final values we get from parsing the file. And then we create what seems like an infinite for loop. And what this is going to do, just in general, is it's going to read the file line by line, and then it's going to break when a line of the file returns nil. And when a line of the file returns nil, or more specifically io.read returns nil, it means that we've hit the end of the file and that there's no more information to parse after that. So we do this by saying if s equals nil, then break after calling io.read. And by default, io.read only reads one line of a file. In a minute, we'll go over how to read the entire file at once or read a line in a different way. So we say if s equals nil, break end. And then, now since we've said s equals io.read and we know s isn't nil, we can actually parse the number out of the string that we've gotten from io.read. So we say s equals string.match, and we give s as an implicit first parameter. And then we say %d plus, which means one or more numbers. So if we look in the input file, each of these has one or more numbers, one or more numbers, one or more numbers, one or more numbers. And so we're looking for those, and we're only going to take those from string.match, and we set s to it. And then we say the t at size of t plus 1, which just means the position after the last position in t, equals to number s, which basically just means s, except we're converting it to a number. And then in this for loop, we just print out all the values of t. So if we run this, we get 2301, 150, and 10, which is all of the number values in this text file. So we've properly parsed the file, and we've done it line by line, but it's also possible to do it in a bit simpler way without this kind of ugly looking infinite for loop, and also without this equally ugly looking if statement here. So what we can do is we can get rid of all this, and then we can use another function in the IO library, and we can say for s in io.lines, and then this should do the exact same thing. And it does. We get the exact same output. We can even get rid of one more line here. We get the exact same output with quite a few less lines and more clean looking code. So parsing files like this, just reading line by line in a for loop and then doing something to the string that we get in each line and then adding it to a table or something. But basically just reading the file line by line and getting a string from that, and then stopping the for loop when one line returns nil, which means that the file is done, and we've read the last line. That's such a common operation that the Lua creators have created its own function for it, and that's io.lines. It does the exact same thing that we did in our for loop before. It reads the file line by line, checks whether the line returned nil, and if it does, it stops the for loop. So we can do this in a generic for loop now, and it's a lot cleaner. And now the last thing to go over in the simple IO model is the different parameters you can give to io.read. So we can have some pretty simple examples here, and we can just keep with the text file we have. So by default, the io.read function reads one line. So let's go back to just printing our result. And if we want to explicitly say that we just want to read one line, and this will give us the exact same results, except we're just saying it explicitly, we give io.read the parameter as a string *L. So this is another kind of pattern matching code, and I'm sure you're tired of those by now, but there are quite a few more to go over in Lua. But this is a much simpler system. Basically all this is saying is I want to read one line and also ignore any new line characters, and we'll get to that in a second. So this will have the exact same effect as just calling io.read without any parameters. It gives us ID and then the random number, which we would also get if we just gave io.read no parameters. The next pattern you can give it is *L, and this will probably give us the same thing too. No, it doesn't. Or it gives us a very similar thing. What io.read with the *L does is it reads the line, and it also includes the new line character that's at the end of each line. So you can see here I hit enter to go to the next line, so that adds an implicit \n here. You obviously don't see it because it's just a new line, but it does add an implicit \n. And the *L just keeps that, so we have the \n that was in the string that moves us down to this line, and then print adds a \n at the end of its output, so we go down to this line. So that's *L. *A reads the entire file. So if we run this, we get our entire file, new lines included. Star n only reads numbers, so we get nil here because it will only read if it again reads it line by line, but it will return nil unless the line is only a number. So if we have this, then it works. We get 2301, but star n only works if the line that you're reading is just a number. It can't have any extra characters in it. It basically just calls io.read with star l and then calls toNumber on the output, or on what it gets from the input file. So the final parameter you can give to io.read is a character limiter. So say I only want to read this many characters. So if we were to say 5, we have to change, sorry, my dog's barking, 1 second. Sorry about that. So like I was saying, we have to change this back to ID and a colon here to get the effect. So now if we run this, we get ID colon space 0, and if you'll notice, that is 5 characters long, which is what we pass to io.read. So if you give io.read a number, it'll read that many characters from the file. So we could give this 100, and it reads the whole file. Give it 20, it'll probably still read the whole file. It actually doesn't, so it reads ID, not sure what my cursor's doing here, ID, and then the random number, and then health 15, and then it stops. So the 5 here is the 20th character in the file, apparently, so it stopped reading there. So this isn't really useful with small numbers, but just for speed purposes, it's faster to read a file in chunks of, I think it's 255 megabytes or something, or maybe 255 kilobytes. But if you have a huge file, it's faster to break it up into small chunks and read it section by section. So this is a good way to do that with this parameter to io.read. So that's all the parameters we can pass to io.read, and now we can move on to the complete IO model. So the complete IO model allows us to be a bit more specific, and rather than changing the current input for the entire program, allows us to, say, have multiple inputs and multiple outputs that all work separately. So to use the complete IO model, let's create a file that we're going to open, and we'll start with output as usual. So say local out equals assert. This is just to get better error messages if something fails. If you don't know what assert does, we'll go over it in a later video. So just put this colon assert. So assert io dot open, and as the first parameter we give it the file name, so outputs.txt, and as a second parameter we put the mode, and we want to read or write to this, so we give it a W. Then we close both the parentheses, and now if we want to use this to write, we can say out colon write, and then we give it whatever we want to write, so hello. Then we run this, and you see we don't get anything. And if we look at our output file, we get hello. Add some letters after this. Run it again, and again we don't get anything in the console. But if we check here, we get hello and a bunch of random letters. So as you can see here, instead of just having one current output, we have an output that we've created that we can only output to with this out object. And you don't really need to know what type this is. I don't even know. But it's basically the same type as the standard out and standard in objects that we were using. So this is a much more specific and better, in most cases, way to do this, because without changing anything here, without resetting our current output or anything, we can now say io.write hello, and we'll give it a \n just to make things look better in the console. And now if we run it, we get hello right here, but we also get hello in our file, and I put this lowercase h here for a reason, so we'll get the hello with a capital H in our output file. So Now we have two separate outputs. We have the output that we access with out:"write, and then we have our normal io.write output, which is our standard out at the moment. And then we also have our output.txt output here. And it's similar. If we want to use input, we say inp, and then we'll change this to input.txt, input, and we change this from W to R, and now we can say print, whoa, that is not inp at all, inp:"read instead of write, and we'll just read one line from our old file, and then we can also print io.read here. So we have one print of inp:"read and one print of io.read. So let's see what the difference is and what happens. So our first print command printed id: the random number. So it got its input from our input file instead of the standard input, but our second print function, or the second io.read function more specifically, is still using our standard input, which is the console, for input, so we have to give it something. So we give it something in the console, and then it prints that out, because the io.read function is still using the standard input, but our inp:"read function uses our input.txt file. So the complete I/O model opens a whole new area of possibilities. We can now have multiple input files, multiple output files, so you can write to multiple files at once, read from multiple files at once, and do all sorts of cool things that you couldn't do with the simple I/O model. And if you're familiar with the C input and output systems, then you'll notice that this is actually kind of similar. And just like the C input and output system, we have to close our files. So when we're done reading from the input.txt file, what we say is inp:"close, and no parameters. And this prevents memory leaks, and yes, again, memory leaks can happen in Lua if you do this. I think if the file goes out of scope, then it'll automatically call inp:"close, but you want to call it explicitly just to be safe. So this ensures that the file's closed and that the handle to the file isn't taking up memory anymore, and that the file's gone now. So, or the file's not gone, but the program's knowledge of the file is gone, and any memory it took up is now gone. So call this when you're done with files. This also applies to output files that you open with the io.open. So just make sure to do that. So now there are just a few more really small things we have to go over. So say you want to write to the standard error stream, which is where any errors you happen to make in the program are sent to. So if we say standard error : write, and we give some kind of odd error message, then what this will do is it looks like it's just printing normally, but actually in the background it's creating errors. I think I'm going to a new program for the first time this series. This is the program I used in the old series. Whoa, there was almost just a car crash outside. I think if we do the same thing in this, we'll actually get red text. So standard error : write. Let's write error this time. Now let's see if I remember how to run programs. I think I just click this. It didn't like that. Oh, that's because this is Lua 5.1 interpreter, and this is a Lua 5.2 interpreter. Oops. I'm messing all sorts of things up. Here we go. Just open ZeroBrain again. Up the size of this. So you can't really see it, but this is actually printing to a separate separate input or output file than our console. It's printing to what's called the error stream, and that allows us, or if you're really trying to complexly debug, it allows you to kind of capture that in an easier way and work with it better. So you won't use that much, but just in case you need it, or just in case you're used to the C file system or C output system and you like using that in C, that's how you do it in Lua. So the next few things are just a few more operations you can do on files, and these are all pretty much the same as their C counterparts. I can't keep on doing, that's unfortunate. So if we have an output file, so we'll say local out equals assert io.open our output.txt in write mode, not to mode, write mode. And now say we have something in this file. We do, it says hello. And all we want to do is we want to get rid of that. So we can say out : flush. And this just clears your output file. If we run this, nothing comes up in the console, but hello is gone. So that gets rid of anything in your output file. There's also file : seek, and this is a bit more complicated of a function, and it's used on input files. So we'll change this to input.txt, change this to read mode, change this to INP, and we can get rid of this. So let's say we were reading through this file, so we go print io.read. So we've read this first line, and now the next call to io.read will read the second line of the file. But say we don't want that. Sorry, my dog's barking again. 1 second. Okay, sorry about that again. So say instead of reading the second line of the file, we wanted to read the first line again. So what we would do, we'd say inp : seek. And the seek function takes two parameters, both of which have default values. So we will say set, and this means the beginning of the file, and we'll leave the second value as default for now. And then we will print io.read again. So now if we run this, it doesn't print anything. 1 second. Oh, that's because we're using io.read, not inp : read. My fault. inp : read. And inp : read. So now if we run this, it still doesn't work. And, oh, it's not that it's not working, it's that the program isn't ending. 1 second, I'll fix this. Alright, not sure what's going on there. It started working as soon as I stopped the recording. So if we run this, we get the first line printed out twice. So inp : seek with the set parameter just returns the current position of the file to the beginning. You can also give it cur, which just keeps the current position. You'll see why that's useful in a second. And then end gives you the end of the file. So we can also give the file.seek function or io.seek function a second parameter, and that's the offset. So let's set the offset to 5 and run this. So we get the first print is the complete first line, and the second print is the first line starting at the 5th position. So 1, the I is the first, D is the second, colon is the third, space is the 4th, and 0 is the 5th. So it actually starts at the 6th position, where we're just skipping the first 5. So the second parameter you give to io.seek, I'm sorry, I'm used to the C library, to io.seek is the offset in characters that you want to start the seek at. So you're basically just setting the place where you're going to start to read next to, in this case, the beginning of the file plus 5 characters. I think you can also set it to, say, end, and then minus 5 characters. I think you can give it negatives. Yes, you can. So what we did here was we printed out the first line just like before, and then we set the position to the end of the file, and then went 5 characters back. So this is the last 5 characters of the file. You can set it to cur and 5. So what this did was it read the first line normally and then went to the second line, skipped the first 5 characters of the second line because it went to the current position plus 5 characters. So it just prints the last H in health and then the colon space and then the 150 number for health. So this just allows you to jump around in the file, and it also returns the current position of the file just in characters. A new line is just a \n, which is a character, so it'll just print out the character number of the new position of the file as a return value. So that's the io.seek function, and that's all the extra functions. Now, the last thing I'm not going to really show because I have no good way to make an example for it, but this is just how you read binary files in case you ever have to. So it's just a simple modification to this, and if you want to read from a binary file, as the mode you give it RB. If you want to write to a binary file, as a mode you give it WB. And this lets you read in binary, so in case you ever need to do that, that's how you do it. But again, I don't really have an example for this, so I'm not going to show it. It's pretty self-explanatory. But yeah, that's all that's left in this video, so in the next video we'll go over the operating system library, which gives us a few more wonderful pattern matching codes, which I'm sure you're excited for after last video. So that'll be next week, so I'll see you then.